This Python service has 9 open dependency alerts. In the next 5 minutes, you'll see an automated triage process decide which of these alerts can actually hurt the service, open a tested fix for that of the 2 that matter, and record the evidence for deferring the rest. Some of these alerts look scary, like, hey, catastrophic. But Severity cannot tell you which ones matter. It tells you the worst case if a vulnerability is exploited, not whether the vulnerable code actually runs here, whether anyone's exploiting it, or what the asset is worth. Triage has 3 jobs. Filter out the alerts that cannot hurt you, prioritize the ones that can, and characterize the signal so a reviewer can actually check the reasoning. Engineers usually do this by hand, but not well because it's very time-consuming and error-prone. So they often don't do it at all. But here it runs on a schedule in continuous integration with the agent tools and licenses that your engineers already have. So a scheduled GitHub Action ran this morning. The agent in this case was GitHub Copilot with Sonnet 5, and it analyzed each alert's reachability against the actual code, and K9 scores the risk. Of the 9 alerts, there's 0 that are fixed today, 0 that need to be reviewed, 2 that should be scheduled for preventive maintenance, and 7 that can be deferred. That is 78% of the dependency alert pile removed from the team's plate. And the analysis retired 2/3 of the total assessed risk. Every recommendation carries its own evidence. So the catastrophic backtracking alert schedules because customer submitted URL strings reach the vulnerable parser directly. However, it's not exploited in the wild at this point. According to EPSS, the vulnerability ranks in the 87th percentile of vulns likely to be exploited, which is well below the 99th percentile threshold, would trigger immediate response. So because it's not exploited in the wild, it's not an emergency, but it is a real vulnerability, so it gets a date to schedule it. The language we use here is NIST SP 830 risk. Your security team and auditors already speak it. So you can see here it's rated on the NIST scale as a moderate, or 50 out of 100 on the semi-quantitative scale. And this started off as an 80, a high, but because it's not being exploited, it was knocked down. 30 of those 80 points were resolved through real evidence about exploitability. Now, by contrast, each of these deferrals is earned in the same way. It's got the same evidence bar, so we evaluate reachability and exploitability. And deferred means the vulnerable code path can't run here with the reason that's recorded. So for example, in this group of alerts right here, the code is not reachable because one of the conditions in the advisories is not met. In particular, check link never sets a cookie header. It never sets a proxy authorization header, and so on. So the code that is vulnerable can't actually be activated in this service. For the 2 findings that were worth fixing, the action already did the work. It created a branch, it bumped the version, ran the test suite against it, and opened a PR because the test passed. Both scheduled findings in one pull request. A reviewer merges it, nothing merges itself. Now, the team hears about this triage report and the pull request in the same place they already work, Microsoft Teams. The card links the run and the report. So I can pop this open, and it goes to the same place. No new dashboard or screen to juggle. So how did the scoring know customer input reaches that parser? Your team wrote it down once in a small file. The file describes where the code executes, For example, this is like a runtime execution context. There's also a build execution context. It describes what the asset is worth. In this case, it's a tier 2 criticality. And it describes how data flows in. So there's a bit about the deployment here and the network exposure and so forth. Your agent drafts it with you in about 10 minutes following our guide, and you commit it like any other code or configuration. K9 never sees your source code. The agent reads your code where it lives, and only findings and context go to K9 for scoring. Now, when context is missing, the product says so instead of just guessing. This is a key way to eliminate false positives. So on this published 272 alert run, 3 findings came back as needing review. The agent had a question that was unresolved, and so it said, hey, I need you to review, engineer, maybe add some context before it's going to make a decision that is wrong or unsupported by evidence. So what this means is that better context in yield fewer reviews out. So, and let's just zoom back up to the top here. Does this whole process hold up beyond 9 alerts? Yes. This is a published run for Redash, which is a business intelligence product, 272 alerts, which resulted in 664 recommendations, verdicts, we call them, across 4 different execution contexts, a server, a worker, a browser bundle, and then the build process. Those are all different places where code can run and have different conditions for their execution. Only 29 need attention. So about 90% of the pile can be deferred with evidence, and you can focus on the 10% that actually matter. And you can read this whole report yourself. Every verdict and recommendation is going to show its own work. With K9 Reachable Risk, your engineers use their current agents and licenses to triage dependency alerts quickly and correctly by adding K9's discipline and scoring. Start at k9security.io and set up the CI automation from the guide in an hour.